Hi, this is Mrs. Jones here, and in this session we're going to be looking at the periodic table of elements. So this is a copy of the periodic table that you will get in your WJC exam. That's whether you are sitting double award or separate science chemistry. Okay, you will receive this periodic table, so you need to get used to using it. You need to understand what the symbols are and what the numbers mean. So we're just going to start an introduction into that this evening. So this here is a different version of the periodic table. You'll notice that all the elements are in the same places, but what this periodic table is really good at highlighting is the fact that an element is either a metal or a non-metal, and most of the periodic table are metals. So this section here, these are all metals, so the left side of the periodic table, and this section here, okay, on the right top part of the periodic table are your non-metals. Please notice that we've got hydrogen here. That's also a non-metal. And what is actually splitting these, I tend to call it a staircase, is the staircase starts between boron and aluminium and then just goes down like that. And that is what actually splits metals and non-metals. Now, these here on the staircase are called semi-metals, but we'll look into that in a little bit more detail later on. I just wanted to highlight the fact that we have non-metals here, okay, and then our metals here on the left hand side. So going back to the periodic table that you'll be given in your exam, the first thing I would be looking at is actually marking the periodic table, just to remind you of certain things, and that will help you complete any of the questions that you're asked. Okay, so what I'm going to do, I'm going to draw this staircase on, and you'll see how easy it is to draw on your periodic table. So you go between boron and aluminium, obviously I haven't got a ruler, so I'm doing this freehand, and that is your staircase then. Okay, so everything up here on this side are your non-metals, and on this side we have your metals. Okay. The next thing I want to draw your attention to on the periodic table are groups, and they're called groups, but they run down. Okay, so if you think of them as columns, many people think of them as columns, but actually they're called groups, so the groups run down. These in this central part here are called transition metals, but we're not really going to look at those all that much this year. They'll be more so in year 11. So I just want to draw your attention to these groups that have been coloured here for you, okay? And what you'll notice is that elements in the same group behave in a similar way. Okay, so elements in the same group behave in a similar way. And what that means is everything in the same group has the same number of electrons in its outer shell. And we haven't really touched upon outer shells yet. You know what a shell is from the structure of the atom video, but there is more than one shell, and the outermost shell has the same number of electrons, and they behave in a similar way because that is the electron that is associated in or involved in a reaction. So going back to our periodic table of elements that you would be given, if you can see, okay, on this your groups are numbered. So this one is group 1. Oh, excuse me. This one is group 1. And then we have group 2, group 3, group 4 going down, 5, 6, 7. And this last one is called group 0. Okay. The reason why they're all in group 1 is because everything in group 1 has one electron in its outer shell. So that's everything in this group here. Everything in group 2 has 2 electrons in its outer shell. Okay, everything in group 3 has 3 electrons in its outer shell, and so on. Group 4 has 4 electrons, and you get the gist. And that is the same with every group other than group 0. Now, group 0 has 8 electrons in its outer shell. Okay, so group 7 has 7 electrons. The only exception to the rule is group 0 has 8 electrons in its outermost shell, and that is the same for all of them. So going back to our group slide, so it says elements in the same group behave in a similar way, and that is because the group number is the same as the number of electrons in the outer shell. Okay, and that is why they behave in a similar way. So the next part that I want to focus on are periods. Okay, now periods are horizontal. So some people like to call them rows, but they are actually, the proper name is a period. So the periods run across like this. Okay, so this one would be period 1, period 2, period 3, period 4, and so on. Okay, now the number of periods also tell you how many electron shells there are. So anything in anything in period 1 will have 1 electron shell. Anything in period 2 will have 2 electron shells. Period 3 have 3 shells, and so on. Okay, and we'll look into, don't get hung up on that if you're not quite sure what that means at the moment. We will be looking into electron shells in a little bit more detail, and that'll, if it hasn't sunk in already, it will sink in, so don't stress about that. So going back to our periodic table of elements, what you will notice is that unlike groups, okay, their periods aren't numbered. So I always find it very handy to number the periods, and I always go from the right hand side, and the reason for that is, can you see that helium, and hydrogen, they are the only elements in period 1. Okay, a mistake that people make is they start numbering their periods from this side and they forget about hydrogen and helium, and they actually start numbering here. Well, if you're saying that that's your first period, actually that's wrong, because that's your second period. Okay, so the only elements in period 1 are hydrogen and helium. So that's period 1, period 2, period 3, period 4, 5, 6, and remember they're all going across that way. Okay, so these are horizontal, whereas the groups run vertically. Okay. Okay, so I don't really like this periodic table because of the way they number in the groups. Completely ignore the way that they number in the groups, but I just want you to focus on the states of matter on here. Now you're used to using or you've come across states of matter, and you would know that states of matter are your solids, your liquids, and your gases. Now if you look at this here, you will see that anything that is white is a solid, and you'll notice that the majority of the elements in the periodic table are solid. Okay, then we have our liquids, and sorry, I need to make sure you understand this. This is at room temperature, and when we say room temperature, we're talking between 20 and 25 degrees. So at room temperature, all of these elements are going to be solid. Okay, there are only 2 elements that are liquid at room temperature, and that is mercury and bromine. Okay, and the last thing we're going to look at then is which elements are our gases. So every single element in group 0, forget this here, is group 0, every single element in group 0 is a gas, and actually this group are called the noble gases. Then we have these elements here, they're gases. So we have nitrogen, oxygen, fluorine and chlorine, and then our hydrogen. Remember, on our periodic table, hydrogen is here, okay, but that's a gas. So everything in group 0, this side was L, and our hydrogen, okay. Now, if you wanted to mark that on your periodic table, you could put, I wouldn't mark all of the solids, you'll be there for a long time, but you might want to put a little L. Oh, I keep doing that, sorry. Might want to put a little L there for your mercury. Remember, mercury is liquid at room temperature, and the other one was bromine. Okay, and then you could mark off your gases, which is nitrogen, oxygen, fluorine, chlorine. You could put a little G, might even want a little key somewhere. And then all of your noble gases, which is your group 0. And they're actually called noble gases because they don't react with anything. Okay, like the nobles don't associate with the peasants. These noble gases don't associate themselves with any other elements, okay? And that's your gas. Oh, sorry, that didn't even look like a G, does it? I don't really know what it looks like, but you're going to do it much neater than I am on your periodic table. Okay, so that is all for this week's session. You need to complete your task on Google Forms. As always, any problems, contact me on Google Classroom and I'll be able to help you. Okay, thank you guys. Stay safe.